Okay, let's get moving on this. This is 622. It's video 139. And we're still talking a little bit today about perfect squares because we're going to need them going ahead. So I'm going to very slowly, there's number 3, there's number 1, there's number 2. Okay, and notice I'll focus on the first one, then I'll focus on the second one. And this is what high school kids have to do. So let's focus on the first one. And again, we're talking perfect squares. These happen to be, the first two happen to be perfect square trinomials, as we said. And when we look at how we want to factor this, you really have to recognize that, because if you didn't, you'd be multiplying 16 times 81, and then you'd be looking for a number that's going to add up to 72. However, I'm going to first do it the way most kids do it, and then I'm going to show you that this business of multiplying 16 times 81 works as well. Okay? So as we look at this problem here, the numbers, the first thing we notice is the numbers are very big. And we say to ourselves, wow, they don't usually do that, 16 and 81. And there are two variables here, but it turns out, as I've told you so many times, it's the coefficient that counts. And 16 is a perfect square, 81 is a perfect square. So high school kids have to recognize that in math. You have to recognize that. And so we can't be sure that this is a perfect square trinomial unless the square root of this times the square root of this times 2 equals 72. So I'm just going to talk about some general things that we do. Square root of 16 is 4. The square root of 81 is 9. 9 times 4 is 36. 36 times 2 is 72. That's the way mental math people do it. It works that way. Let's just go over the idea again. 16 times 81 is some big number. We're guaranteed it's a perfect square because a perfect square times a perfect square is always a perfect square. But instead of knocking ourselves out, we can just put the hat over it, as we did all the way back in October of last year. And then again, not finding the product, you just get 4 times 9, which is 36. If you can double that and come up with 72, then you found your answer. And that's the way you expected to do it. And I justified how it would work. Okay? So if there were 36 here, it wouldn't be a perfect square trinomial. Any other number but 72. But it works. So now we're able to mark it out. And we can write it this way if the teacher asks us to write it out. And I won't do that with the other one, by the way. Okay? Running out of space there, okay? And now, as I work backwards, I'm going to factor this out, and I get 4a here. And what's left? 4a plus 9b. And then we're starting to see what's going on here. If we're correct when we write this out, it will repeat itself, as I've said so many times. And now we do 36 here, and 81, whoops, no equal sign, of course. And we see that the 9 works. In fact, the 9b works. And then I got 4a plus 9b again. But again, I didn't have to do that. By the way, with perfect square trinomials here, notice 4a plus 9b comes up 3 times, but really it's just twice, since this is connected to this and this is connected to the same thing. So the answer would be 4a plus 9b times 4a plus 9b, which of course is 4a plus 9b squared. And you'd be expected to do that, and you'll see what I'm talking about this week as we move along, and we'll do just a little bit more practicing our factoring skills with rational expressions. Okay? So I'm going to erase this now and try to stay out of the way as much as possible. And now I'm going to do the same one. But, so again, this is just saying a squared plus 2ab plus b squared equals a plus b squared, where the coefficients are perfect squares. Okay? And here, the middle term is negative, so we don't really have to knock ourselves out, right? It's going to be 4a minus 9b, times 4a minus 9b. And again, the same reasoning works, it's just that the middle term is negative here, the middle term's positive here. And of course, the answer here would be 4a minus 9b squared. So you'll be expected to spot these guys. Okay? Sorry, I didn't move that over fast enough. You can see what I did. But I think most of you are following me, see right away that this is the way to go. And if you ever get confused, although they only give you the simple perfect squares, you note here that when the numbers are big and they're not perfect squares, then there's got to be some other trick going on. So there's one and there's two that I made clear to you, the different formats of what's going on. And I'll erase this because it should be obvious to most kids who understood number one, that number two just follows naturally from that. And now, again, the math would be a minus b squared, right? And that would be a squared minus 2ab plus b squared. And that follows the format here. Remember here, one is a perfect square, one is a perfect square. So I'm just substituting perfect squares and multiplying a times b. Because again, a squared, the square root of a squared, of course, is a. And the square root of b squared is b. So that's all I did in my head. And that's all that most freshmen do, most high school kids do when they're taking the Regents. Enough to get the answer. And as I'm repeating myself, you'll see why you need some skills in factoring this week. I'll do some problems that require you to be able to factor. And now I take you to the last but certainly not least, and that's this format, which is a squared minus b squared, okay? And they love this, so get used to it. They just love this, okay? It's not to be confused with a squared plus b squared, which I'll show you can't be factored. And it's certainly not to be confused with a plus b squared or a minus b squared. And so those are common confusions that kids come up with. This is its own configuration. It's very important, and they use it all the time. What it's trying to say, excuse me, is that the middle terms go away when you do it this way. So there's no parentheses. It's the a squared minus the b squared, and they have to be perfect squares for it to work. That's why it's under the category of perfect squares. And then I look right away, the same problem. Well, 16 is a perfect square, and 81 is a perfect square. So just like a squared minus b squared equals a minus b in any order, I have to keep saying that. Kids think order matters sometimes. And there it is. So this is going to be the same thing, okay? And again, if I've written it out, which I'll show you in a second, the square root of 16 is 4. The square root of a squared is a. And then same idea, this is 9b. And then you write the conjugate, any order, as long as you write the conjugate. That is where the second term is the opposite of the second term of the other one. And there you have it, okay? And again, if I tried to work this out, the math would do this, which I won't work out completely. Okay? I won't work it out completely, but you'll see that it's 4, so it would be 16a squared, and then it would be plus, in any order again, 36ab minus 36ab minus 81 b squared. And I don't need to work that out because I'm just writing it out, and it's much quicker to work in your head and just do it. But in either case, you could factor these two terms and these two terms and come up with the answer that I just came up with, okay? So let me do a little answer key here so you can see what's going on. You'll see a lot of this. The answer here, if you like that word, is A plus, oops, 4A plus 9B times 4A minus 9B, okay? Perfect square binomial. And as we did over here, 4A plus 9B times 4A plus 9B, and you know that equals 4A plus 9B squared. And here, again, same idea, easy pickings. You do one, you can do the other, and that's what you have to be watching out for when you're in high school, okay? And you'll, like I said before, you'll see what I'm talking about as we go along. So those are all three formats here that we're going to see with two variables. One variable is usually easier for kids, but it's no big deal. And before I move on, because I'm going to give you a multiple choice question today to see if we can work on understanding, I'm going to factor something that you might find a lot of kids find confusing over the years. So I'll just erase this. Okay, and put this on this side. And so we're asked to factor 1 minus x squared. Okay, so I'm going to put that over here. All right, and kids just go nuts trying to figure this stuff out. But if you think about it, there's a 1 here. And you never forget, as long as you're doing math, that 1 is a perfect square. So it's going to be 1 minus x, right, plus 1 plus x. I want you to look at that now, okay? And that becomes, if you do the math, minus x plus 1 times x plus 1. So let's slow up and explain what we did. I reversed the order here, which I can do, as long as I didn't change the terms. And I reversed the number here, which I can do. And then I'm going to factor out the negative 1. I'll put it just like that. And that makes that an x, and that makes it a 1, and there you go. And they love these configurations, so I want you to take a good look at what I just did. And of course, the textbooks are going to write it this way, in any order. So what it's trying to say, if you reverse the order, you become negative. If I did it the other way, it would be positive, okay? So I want you to take a good look at that because they fell in love with that kind of stuff on the Regents. And they love, when we be doing reducing and simplification, they love to throw little things like that at you. So I'll be doing that as well. So take a good look at what I just did there. And I'll move on with a multiple choice video later this morning.